So just to give you a little perspective, I actually work at IBM as a research strategist, which means that I get to go study things and I have absolutely no responsibilities. It's the best job on the planet. So one of the things that I like doing is I actually work with IoT security stuff. In fact, it's not technically my job at IBM. I just got interested in it about 6-7 years ago when I was running my own business. And when I came to IBM, I said, look, anybody doing any connected car security stuff? And they said no. And I said, mind if I do it? And they said, as long as it doesn't interfere with your job. And now that's pretty much all I do. So the goal here is, or the message here is, if you like to do something, just go ahead and do it. And by the way, we're in a negative unemployment industry. So if you get fired for doing things that you like, then there's other jobs anywhere. So it's fine. That's my advice to you. Get fired. So who here has not heard of the Chris Miller and Chris Balasek and Charlie Miller hack? Not heard of. Okay, you all know about it. So the interesting thing about this is that, this is where they had the wired reporter behind the wheel, and then they disabled the brakes, and he freaked out and drove it into a ditch. And this is what the media shows, right? It basically is big fear, uncertainty, and doubt, and oh my God, it's gonna be horrible. It's gonna be the apocalypse, right? So one of the things that I want to do is demystify a little bit about that, and also I want to key on the work of Balasek and Miller for a second. Who here has read Balasek and Miller's paper all the way through? So one of you, okay. That's good, because the reason I say that is I'm actually going to dissect what they did, because it is kind of interesting how they went about hacking into the car. And then I want to show where the car manufacturers actually made mistakes, and we'll talk about that. So how do we learn from the car manufacturers' mistakes? Who here actually works for a car manufacturer? I guess that's the first thing, because we're going to talk about them. So, see, the interesting thing is that the general public thinks about it in terms of, oh my God, our cars have gone completely freaked out. Anybody here a big Stephen King fan? Christine, right? Or if you, actually, I like this better. Anybody know what this movie is? Best B movie on the planet. Maximum Overdrive. Come on, people. All the trucks become animated, and they hold Emilio Estevez. That's all I have to say. Emilio Estevez. Come on. So great movie. If you haven't seen it, absolutely. Get a couple beers on a rainy Sunday afternoon. It'll be awesome. So just to give you a sense of the threat landscape, just from a general perspective, this is kind of a marketing slide, but one of the things I find kind of interesting, anybody ever see this particular chart? So it's a number of lines of code that are in software. In a modern high-end car now, there's about 100 million lines of code, and you can juxtapose that with an F-22 Raptor fighter at 1.7 million lines of code. For most of us who have done any dev, we know this is kind of bullshit numbers, right? Really, 100 million lines includes a lot of operating system stuff, all pre-canned stuff that's brought into it. But the point is that there's a lot of electronic control units in cars. So, one for every wheel, for the brakes, plus also the tire pressure monitor sensor. There are ECUs for the fuel injection on cars. There are ECUs for just about everything, right? So there's almost 100 electronic control units in most cars right now. And they all come from different tier 1 manufacturers who write their own firmware. Then there's the head unit, which is basically not the dashboard, but the thing in the center. So for those of you who aren't familiar with all the terms in the connected car industry, I'm going to go through a few of those. I'll explain them as I go into them. So when I talk about head unit, it's usually the screen that you see where you plug in your iPod and stuff like that. And we'll talk a little bit more about that as we go through. So why do we have all this crap in cars in the first place? And the reason is that the automotive manufacturers are trying to accommodate consumers for all kinds of interesting use cases. Things like the ability to keep your kids entertained on their iPads while you stream them videos to it, right? Things like actually also behavior and policy monitoring, going back to kids for a second. If you have teenage kids, being able to monitor where they drive. So if they drive outside of, say, a 50-mile radius of your home, the car can alert you as a parent. Or if they're speeding, et cetera, et cetera. And then obviously they want things like advanced diagnostics, so they want to be able to take all the telemetry from your car and send it back to the service center. So that if your ECU for your brakes keeps sending all kinds of error messages, it's predictive maintenance, right? They say, hey, your brakes are going to fail within a certain amount of time. And in fact, what's going to end up happening, or at least this is their vision, is that the service center will then schedule an appointment for you, because if you think about it, you got your cell phone that connects to your car, and that's what they want to happen, right? You get into your car, everything on your cell phone transfers into the head unit, including your contacts, your schedule, et cetera, et cetera. Your phone goes dormant, the car takes over, right? So now the service center can now schedule, because they have access to your calendar. They say, hey, we think your brakes are going to fail. We've scheduled your appointment for Saturday at 9 o'clock. Anybody want your automotive service center to automatically put things into your calendar? Come on, people. That is the allure of the IoT. That's going to take over our entire lives. It's going to be awesome. So let's look at a little bit of background here. There are 2 seminal papers that were written by University of Washington in collaboration with the University of California at San Diego. And so what they did is, in 2010, they did this study on cars, and they said, what happens if you break into a car? How far can you penetrate? And it turns out, as long as you have access to the OBD port on a car, you can pretty much take over the entire car. It's hard and crunchy on the outside, soft and chewy on the center, as we used to say in the firewall days, right? So they could do things like, once they jacked into the car, they could actually apply the brakes even when the car was going at 40 miles an hour on jack stands, which should they could disable the brakes or apply just the left brake and not the right brake. They could pretty much control everything. In fact, they wrote a piece of software called CarShark, where you could actually toy with all the electronic control modules in the car itself. So interestingly, the automotive industry kind of said, not that impressive. And in fact, if you look at, if you saw back in 2 years ago, Valasek and Miller showed up on the Today Show, and they pretty much hacked into a Prius and an Explorer, and they showed the general public, right? And the general public went, oh boy, you can break into this. However, the car manufacturers said, we don't really care, because Valasek was sitting in the back seat. There was a big data cable snaking up to the front of the car. Oh, and by the way, the dashboard was completely dismantled. It's going to be pretty obvious if you get into the car that somebody is jacked in, right? So they were like, we're not so worried about it. You need to have physical access. So what ended up happening after that is that in 2011, so I went a little bit fast forward, right? So there's the seminal paper in 2010. The auto manufacturers were like, it's kind of interesting, but not that interesting. Go about 3 years later, and Valasek and Miller actually proved that they could take the work of 2010, and they showed how it worked. But go back for a second to 2010, and the researchers said, well, you can do this from the outside too. So they did another study in 2011, and they published a paper, and they said, yeah, the threat surface on a vehicle is actually pretty damn broad. Things like OnStar and Uconnect, you've got Bluetooth, you've got the cell network that connects into your telematics unit, which is part of the head unit. You've got things like short-range RF, which is basically for vehicle-to-vehicle and infrastructure-to-vehicle communications. So think about the use case there, right? You're driving along and you go look at your text. I know you're not supposed to, but you do. Come on, let's face it. And as soon as you do that, the car in front of you slams on its brakes. Now it sends a message to all the cars in the surrounding area that it just slammed on its brakes, and then your car waits a certain amount of time, and if you don't press your brakes, it automatically applies brakes. That all happens through vehicle-to-vehicle communications. Same thing for infrastructure-to-vehicle communications. If you're coming up on a really fast turn, and you're supposed to be going 40 miles an hour, but you're approaching at 60, the infrastructure can tell your vehicle to slow you down to 40 miles an hour. So those are the kind of things that are being instrumented into vehicles now, in case you didn't know. So these researchers, when they did all this, they went the full, they went from the kickoff to the touchdown, right? They basically said, we're going to go ahead and try to break into the telematics unit, right? Because that's the holy grail. If I can sit in my living room and pick some evil country stand, right? So I'm going to break into a car in the United States. That is the holy grail. So they actually proved you can do that. As long as you have cell service, you can get into the telematics unit of the car. And when you do that, they proved in 2010 that once you get access to the telematics unit, you have access to the entire car. Game over, right? In fact, they did all kinds of other interesting things. They actually created a and by the way, with the telematics, they found that you didn't have to have interactive access. They just recorded the cell signals, the audio of the cell signals. They played it over a mobile channel, and it automatically compromised the car. So you could do it without actually having interactive access to it. They also did things like, they found that there was a buffer overflow in the CD playing, the MP3 player in the CD unit. And so they burned some MP3s onto a CD. They put it into the car. It played normally, so Lady Gaga or whatever it is you listen to nowadays, all you young kids. And it automatically buffer overflowed, gained access to the CAN bus, which I'll show you here in a second, and then it compromised everything, and it gave them remote access. In fact, they actually posited, and I think they wrote the code to do this, where they could actually compromise the car, have it call back on an IRC channel, right? So they could control it like a bot. So they actually could create a whole botnet army of cars just by giving you a CD. They also compromised. So you think about the vehicle maintenance. You go in and you bring your car to the service center. And the service center guys, they have these laptops, right? And there's only a few, depending on which manufacturers you're working with. And they plug it into your car, and they diagnose it, and et cetera, et cetera. So they actually figured out which laptops were customized to be service center computers. They compromised it so that when you brought your car in, they plugged it into your car, it automatically loaded malware onto your car through the service center's diagnostic computers. That's awesome. That's a pretty cool hack. They also wrote a mobile piece of mobile malware that when you connect to your car, when you get into your car, it also took advantage of a Bluetooth vulnerability, so that if you got the malware and you had that particular car that had a Bluetooth vulnerability, they could then access your car through your mobile phone. Again, sort of transitive access. So they went pretty far in proving that you could actually compromise a car. So just for those of you who don't really know how a car works on the inside, there's usually, and this is a simplified version, I've seen cars that have 11 separate CAN buses or networks in them. There's usually 3 different buses. And the most important one is the control area network, which is, we usually call it something like CAN-C, CAN-C, for control area network for control. I don't know what the C stands for. Who knows? Anyway, who cares? Different manufacturers call it different things. But basically, when we talk about CAN bus, we're thinking about the one that controls engine, brakes, airbags, things that are critical. That's what C stands for, by the way, CAN critical. It's for critical control systems in the car. It's usually high speed, God bless you, and it is isolated from the other 2. The next one is the local interconnect network. Nobody calls it that. That's sort of academic. But what it is, it's for things like your door locks, your power windows, your lights, things that are not critical controls, but they are chassis controls. So usually people call it the chassis network. And then the last one is your media and entertainment. And by the way, the local interconnect is usually low speed, because who cares, right? It doesn't have to be that fast. It's not critical controls. And then you've got usually something that's for media, things like your CD, streaming stuff to the television in the back so your kids don't go nuts. One of the things that I find really interesting about it is that even though they put these electronic control units, these ECUs, between the 2 to sort of mediate the traffic, think of them as sort of firmware firewalls. And those are the ones the researchers compromised in the first study. They don't actually act as firewalls, because as we've shown, or as the researchers showed, you can basically compromise those. And usually what they end up doing, by the way, is they'll get into one of the other lower speed networks, or the less critical networks, and then they'll figure out a way to update the firmware on this thing, and then it turns it basically into a router rather than a firewall, if you will. But the other thing that's interesting is that most of the use cases for connected cars actually require that you have access to multiple buses at the same time. So for example, keyless entry, right? There's a few things you can do. You can open up the locks on your car, obviously, but you can also turn on your engine now, right? So that bridges 2 different buses. OnStar has access to everything, right? So OnStar, if you get in an accident, it automatically notifies OnStar. OnStar can unlock your car. They can actually turn off the engine if your car is stolen. So those kind of services all bridge all of these buses. And if you have access to the onboard diagnostics port, game over, right? You can have access to everything. So just so you know, this is kind of what it looks like on the inside. And that's what it looks like on the outside. So, interestingly, how hard is it to play around with this stuff? I found out, and one of the reasons I got interested is back in 2007, I have an old car. I have a 2001 car, and the GPS CD player, because I had to put a CD into it, right? It's before, yeah, you know, the CD player and the GPS, the old GPS, right? It wasn't even DVD at the time. It broke, and you have to replace the whole thing. So I went on eBay and I bought one, and I figured out how to put it in my car. I stuck it in the car, and it wouldn't turn off, so it kept killing my battery. So I was like, I'm an engineer, I should be able to figure this out. So I go on the internet, and I found schematics for building a controller area network to serial port interface. So it only required about 10 different discrete components on a breadboard, and I've done some soldering, so I got it together and I soldered that thing up. It was ugly as hell, by the way. This is it, in case any of you who are soldering any makers, it looks like hell, but I did it. And then I found on the internet software that actually, once you plugged it in, by the way, so it gave me a serial port interface onto a laptop, but then you had to have bare wires and cram them into your wiring harness. It was really ugly, right? And I'm not that good a maker, so I didn't bother putting a little pigtail on there or anything like that. I just crammed it down in there and it worked. And I got the software out the internet and I could watch the messages go back and forth on my car's network. So I would turn on the key and it would say key in lock position 0, 1, 2, tell me when I turn on the lights. And you could actually reprogram it so that if you put your lights, you put it onto high beams, it would actually just put your lights off. You know, you could just reprogram the whole thing through it. It took me 2 hours. I didn't know shit about cars before I started this. Nothing. The internet is awesome. Nowadays, right, that was 2007, you can go online and you can get an OBD2 wireless connector. So you can buy it for about 40 bucks on eBay or SparkFun or wherever you're buying your electronic stuff. Put it into your OBD2 port on your car, go sit in your living room with your laptop and hack the hell out of your car. So it's out there, and one of the things that people say is that, yeah, but you don't know all the protocol decodes. OBD2 is not necessarily, you know, it's not a well-published standard, right? Because it is a little bit obscure. But you can go get the protocol decodes online. There are a lot of them. Manufacturers do different things on the CAN buses with different types of ECUs and things like that, but the general protocol decodes are available. It's pretty easy. Plus, if you really want to play around, the Vlasic and Miller also created a building your own car lab handbook, where you can actually take a chassis of a go-kart and you can cram real components, right? So if you've got a Chrysler, you can go buy Chrysler components and cram them into this go-kart, and now you can hack around with it. So basically, you can build your own car hacking lab. And then, of course, online, there's the car hackers handbook, right? Owner's manual. So all this stuff is actually pretty damn easy. Now, I tell you this because here's the problem, is that the car manufacturers have been around for about 120 years making cars. They're used to making them mechanically. It's a pretty Kabbalistic type of industry where they think what they do, because it's so sort of obscure, that nobody else is going to be able to figure it out. But that has long gone, right? And so this is how I liken it. I'm going to switch gears for a second. So I was working with this guy a long time ago. He got hacked. I was running my own company. This guy got hacked. He was running an e-commerce website. They stole our certificate, right? So we went in, we did the forensics, we got him back up and running and all that. And I said, one of your problems that you have here is that when the server starts up, you've got a file that has the passphrase for your certificate on the system, and they just catted it, you know, in the startup script so that it would automatically unlock the certificate. So I was like, you can't do that anymore. When you start this thing up, you are going to have it notified, and you have to log in interactively. There's not really a good way for you to have it automatically start up and unlock the certificate. And so he had this other dev organization, and they were like, wait, we've got an idea. We can solve this problem. I was like, all right, tell me. So they go, we're going to hide the passphrase in a binary. And I'm like, what? What the hell are you talking about? They go, we're going to split up the passphrase, and we're going to code it into an executable. It's going to be awesome. And I was like, okay, that sounds like a lot of work. Now, how does this work again? And they go, oh yeah, when the server starts up, we're actually going to run the thing, and it'll spit out the passphrase. And I'm like, that's really stupid. So instead of a hacker who actually gets into the system, having to go do cat passphrase.txt, now you save them 6 characters. All they got to do is, you know, /cat passphrase, right? So it was the most stupid thing I've ever heard. But this is the way some people think. And I'm not saying that the automotive industry is thinking that, but my point is this: that people they use obscurity as a method of security, and we know that's just plain bullshit. So, all right, so let's talk about Vlasic and Miller for a second. How did they break into the car? They did a few things. Number one is that they found out that you could actually break into the in-cabin Wi-Fi, right? So a lot of cars now have Wi-Fi for the vehicle. In the Jeep that they had, right, which is a Chrysler product, which is owned by Fiat. So anyway, you get the point. That you have to subscribe to Uconnect, which is their version of OnStar, in order to have access to the Wi-Fi. But if you do, what ends up happening is that there is a default password. It is WPA, which is great, and it requires 8 characters. alphanumeric characters if you do change the passphrase. But the password by default is a random character. Anybody see where this is going already? Right? So there's a few things that happen. First off, it actually, and I don't think I have the code for that one. But anyway, what ends up happening is that the head unit boots up, and it has the Wi-Fi module. The Wi-Fi module queries the clock as part of its the way that it actually gets the it randomizes, right? So it calls rand with time, right? Everybody knows what I'm talking about here. So effectively what ends up happening though, there's a race condition where the clock chip hasn't quite yet set the time by the time the Wi-Fi module boots up, so the time has not been set. So it actually gets a default of January 1st, 2013. So pretty predictable. About, Valasek and Miller found that the boot up time is about 30 to 32 seconds after the Wi-Fi module gets its password, about 30 to 32 seconds after the car boots up or after the head unit boots up. So you actually reduce the amount of time for randomization to about, within about 5 seconds of a particular time. So you knew that rand time actually gave you certain values. It was pretty easy to predict at that point what the default password set was. Right, so even without that, using time as a way to randomize, as the only way to randomize, is not particularly bright. We know that already. Anybody here know that already? That's why I like being at dev conferences, when you're actually talking to people about security. You guys get it. So what they also, but then they were like, well, that's kind of a pain. We don't really want to use Wi-Fi in that particular, well, actually, I'm sorry, I'm getting ahead of myself. So they connected up to the Wi-Fi, and then they started scanning, and they found all kinds of interesting ports on there, right? So a lot of them, who the hell knows what they are? This is pretty obscure stuff. It's a head unit made by Harman Kardon. But they did find something really interesting, which is port 6667 is open. No matter who you are, that's interesting. Why is IRC running on a car, right? So one of two things happened. Either the car has been hacked already before they even got to it, or somebody, I don't know why the hell they choose 6667, but it's kind of interesting. So they started poking around at it, and what they find is that it's actually it's a login to QNX. You guys know what QNX is, right? It's BlackBerry's Linux-like variant that runs on a lot of IoT devices. So they log in, and what they find is that all you need to do is type in auth anonymous, and you have anonymous access. So effectively, there is no password to this thing. So as long as you have access to the in-car Wi-Fi, you can tell them that to 6667, log in with anonymous, and you have access to root on the QNX system that runs a head unit. Make sense? Letting that sink in for a second. That's pretty damning, right? So next thing they did is they said, all right, how can we use this to actually, so in the way it works is that you've got the head unit, you've got QNX, which runs a lot of the telematics types of stuff. But then you've got the CAN bus unit, which is supposed to be separate from it. You're not supposed to be able to get from the head unit to the CAN bus. Is how it works out. So they needed to figure out a way that you could actually get from that QNX instance on the head unit over to the CAN bus. They wanted to be able to send CAN bus messages from there. So what they wanted to do is they're figuring, okay, what's next? Can we actually do something from that head unit to gain access to the what's effectively it's a V850 chip. That's the thing. How do I explain this? I should have a picture of this, to be quite frank with you. So you've got QNX here, and it's separated, but it's also connected to a V850 chip. The V850 chip is actually what controls the CAN bus. So they wanted to figure out how they could get there. So effectively what they did is they wanted two things: to get access to that, but also not to have to be connected to the Wi-Fi, right? Because you want to be able to do that from anywhere in the world. You want to be able to hack into that car from anywhere in the world. So they were looking for a few things. One of the things they wanted to find out is how can they actually, can they set some sort of, can they root this system? Can they install their own software on it? And effectively what they found is that there's a few things that they could do. You can actually update the ISO image on a particular, on the V850 chip, because it allows you to update it. But the problem is that the head unit, when it goes into an update mode, and so does the V850 chip. So they didn't actually have access to both at the same time, because when the head unit goes into update mode, it knocks you offline. So they didn't have access to be able to update the V850 firmware to give them access to the CAN bus through the USB, through the head unit. So they had to do a few things, right? They had to figure out how to overcome the fact that, that the head unit was offline when they needed to update the firmware. So what they figured they could do is, if they could actually write data to the file system on the head unit, then they could actually execute commands when it reboots, and that could actually do the flash. So in other words, they don't have to have an interactive shell to the head unit in order to flash the firmware. So a few things. They did figure out how to do that. Through one way is that the system boot actually allows you to call arbitrary scripts. They did have to get over the fact that it was a read-only file system at one point, but they did figure that out. The other thing that they found out that was kind of interesting is that there were a lot of command injection flaws as well. So you could actually do just about anything, right? So anybody recognize string concatenation as a way to inject commands here? So as long as somebody had access to the operating system, you could actually control this trail path saved variable and execute whatever it is that you wanted to during the execution of that particular script. So they had a few ways that they could get around the fact that they didn't have interactive access to it. So, and by the way, interestingly, there are some fun tools like Netcat that are available, all kinds of interesting development and hacking tools on the QNX system by default. So also not a best practice, right? So again, that's where I call this sort of a DevOps problem because part of it is development, right? This is a horrible thing to do, we all know that. But also, this is a bad ops thing to do. Never leave your development tools and things like Netcat on the system in production. So, so now they're saying, okay, through the Wi-Fi network, we know how to hack into QNX. We know how to gain access to the file system. We know how to put files on it so that when the system's rebooting, that we can actually do things like update the V850 firmware. But how can we do this remotely? So what they found was that even though the head unit was listening on 6667, it was not listening on the entire internet. So you couldn't be on some random provider and gain access to it. But as long as you were on the provider's network, and Sprint actually made Sprint was the provider that is used by Fiat and Chrysler. So as long as you were on Sprint's network, you could actually gain access to port 6667. So at first what they did is they took a femtocell, and so they could sit in their living room and actually connect to the car. The car connected to that. It gave them a little bit more range, but it didn't give them the entire range. But then they went out and they fired up internet sharing. They got a burner phone from Sprint. They fired up internet sharing on it, and they found that they could gain access to it from any Sprint network. In fact, they scanned all of Sprint's network on, I think it was 2 Class B ranges, 24.000 and 25.000, or something like that. I can't remember exactly. And they found somewhere on the order of about, I want to say 200,000 cars that were vulnerable, who were listening on port 6667. It turns out, in the end, there were 1.4 million cars that were actually vulnerable, right? Because that's what Chrysler actually ended up recalling. But it turns out that they could actually, from their living room, on a Sprint burner phone, with internet sharing from a computer, gain access to 1.4 million cars and basically hack them. That was the potential threat that they uncovered at that point. So, the only thing that we've done so far, though, is exploit the head unit, right? So we can do things on the head unit like, you can actually turn the radio volume up to disco and actually disable the volume, right? The control. So if I'm sitting in there could be 1.4 million people sitting in their Jeeps and other Chrysler vehicles, that all of a sudden the volume goes to disco and then they keep playing around trying to turn it down and it will not turn down, right? So it's a lot of mischief, but there's nothing really particularly problematic about that. They could turn the temperature up and down. They could read the GPS telemetry. Now we're getting into a little bit more privacy, right? So you could do something more interesting. They could put a custom splash screen, so presumably you could put porn on everybody's Chrysler if you wanted to, on their head unit, or something equally as interesting. But they couldn't do anything further. So, like I said before, they actually figured out how to update the V850 CAN controller firmware chip. And interestingly, it did not require any cryptographic signature. So you could put anything you wanted to on that chip, right? You did not have to get around any sort of hash value at all. So they figured out how to do that, and there were some limitations on how the head unit actually connects to the V850 chip. But they also found that it listened through serial port interface, right? So it had 2 ways that you can actually get to it. So they could send commands from the head unit directly to the V850 through a serial interface. And it has sort of an API that they could actually use. So what they ended up doing is, and there's a lot of technical detail which is way beyond what we can talk about right now, But basically what they did is they found places in the code, and they used IDAPRO, right? Were anybody here at the Flash Talks yesterday? Or Flash, do we call Flash Talks? What the hell do we call those things? Speed Talk, thank you. Yeah, you guys weren't there? What the hell's wrong with you? Come on. So one of the things, I was on the panel there at the last minute edition, and one of the things that somebody was saying is, if you've got access to, if you want to be able to test pre-compiled code, something off the shelf, then, there is some measure of security in that. And all I can say is bullshit. Anybody here ever heard of IDAPRO, right? So you can gain access to just about anything. So that's what these guys did. They took IDAPRO, they decompiled the V850 chip, which, by the way, all you need to do is suck the firmware off the chip in the first place. You just need to figure out where it's stored, which is not that hard. They did that. There was actually a decode in IDAPRO for the V850 chip, score, right? They didn't have to write too much. They'd have to write a little bit of decode. But for the most part, it was already ready for them. And then they figured out where the commands were actually set, and then they sent them over the serial interface, and bang, all of a sudden they had access from the head unit to be able to send data to the CAN bus. So there we go. Now, the other technical challenge they had to overcome is that the ECUs, if you're going to reflash an ECU, you need to know what they actually have some sort of shared secret between the two. It turns out that on almost all of the ECUs except for one, it was basically just obfuscation. It was a shared secret that was stored in a binary on the V850 chip, I believe, right there in the file system, that once you sucked it off and you figure out what the obfuscation is, you get a plain text string. It was actually pretty easy. So again, using things that are not real cryptographic functions cause problems. So, and then there were all kinds of other things, and basically what they wanted to be able to do, and think about how ECUs work, right? You send some sort of message from the initiator to a destination ECU. You can do all kinds of things. You can listen to the CAN bus messages. You can force drops on different messages. You can spoof the initiator and send a false message to the ECU, or you can flood the bus. And they had to use many of these different tactics for different reasons. First off, listening, because they needed to be able to figure out what the hell the messages were so they could actually send them. In some cases, so for example, I want to get this right. There was one message, I think it was taking control of the, I'm probably wrong on this one because it doesn't sound right in my head, but anyway, in many vehicles now they have lane correction control, which effectively is, there's actuators in your steering wheel. And so you can actually have the steering wheel taken out of the hands of the driver. So the whole point is that the camera looks and it sees that if you're over the line for any length of time, it'll actually correct your steering to get you back into your lane. So you can actually do that on the car. You can grab the steering wheel out of the driver's hands and send them off a tall bridge if you wanted to. So what they found is that when they sent those messages to the steering wheel saying, go right or left, the lane correction control were saying, no, we're not seeing any problems, so don't do that. But what they found is that if you send more messages telling it to turn the wheel hard right than we're sending saying there is no problem, then the volume of messages won. So basically, they just flooded the network with, yes, go ahead and yank the steering wheel right, and it overcame the correction mechanism, which said there's no particular problem. So anyway. Anybody interesting, fun? Yeah? Cool stuff? Anybody here ready to go hack their car? I already showed you where to get the stuff, so knock yourself out. So part of the problem, I just want to point, I know that it sounds like I'm bashing auto manufacturers. I'm not. Think about this. They've been doing the same thing with the same designs for so many years. It takes it takes from 3 to 7 years, I think, from the point of inception to the point of production for a new model car. And they're often based upon previous model designs. So Tesla, on the other hand, by the way, has a leg up on these guys, right? They've had the ability to build cars from scratch without having to have the previous design. And they're basically computers, mobile phones on wheels. But they still have not been immune to problems, right? So they do have some issues. We've seen, for example, on the web portal where you go through and you authenticate with your mobile phone to do all kinds of things like set the temperature and see how much battery usage and all that. There was some authentication issue. I can't remember what it was, but it was some HTTP normal, what we would think of as a normal vulnerability. There was a Chinese contest at Syscan 360 where they did things like open up the moonroof and unlock the doors. So they still have problems. But it turns out because they were built as computers to begin with, they have over-the-air updates. So they can fix these problems much quicker. And so, blah, blah, blah. There's all kinds of problems, we know that. Here's the thing I already talked about vehicle to vehicle and infrastructure to vehicle. Self-driving cars are going to change the game. So here's my scenario, right? Because we like fear, uncertainty, and doubt. What do they call this? Setting scene or something like that? So think movies. So you get this top-down view of Los Angeles, and all of a sudden you see all these cars backing out of their driveways at the same time. And then they're all going to a chop shop, right? So hundreds of thousands of vehicles driving down 101 on Los Angeles. And then the cops come and they're driving after them trying to stop them. And some of the autonomous vehicles start ramming into cops. It'd be an awesome movie, wouldn't it? So that's kind of the fear, uncertainty, doubt. That's never going to happen, by the way, most likely. But maybe. Self-driving cars. Could be fun. So we think about it in terms of that kind of stuff, right? Safety problems, but it's also obviously the privacy problems. Because all your mobile phone stuff's going to be in the car. Somebody breaks in your car, they get all your information. Contacts, email, yada, yada, yada. So there's a lot of stuff to worry about. So is it the beginning of the end? The answer is no, right? So what do we do to solve this problem? So I've talked about all the bad things, how you can break in. Let's talk about how we, when we're developing, can not make these same mistakes. So first off, security by obscurity is ridiculous. So never, don't rely on security by obscurity. And I think I've already talked that to death, right? The other thing is that the problem with IoT devices, they're usually an amalgam of a bunch of stuff bought from different tier 1 suppliers with code to glue it all together, et cetera, et cetera. So one of the things, don't let race conditions foil your security plans, right? So there's not just about randomization, but also password authentication. We've seen with smart meters, IOActive did some research on that, where it showed that there are race conditions where by the time you start to authenticate and by the time something actually occurs, like some operation that you're trying to do, that the race conditions can actually allow that operation to occur without authentication completing, right? So there are cases where race conditions actually cause problems. Get rid of the dev and test tools from your production system. Strip symbols, and all that. Yes, I get that this is a little bit of security by obscurity, but don't make it as easy. Don't make it easy on the hackers, right? So limit the exposed services and ports by not binding to all interfaces, for example. And most important is require strong hashes for updates. In fact, BMW had a problem with one of their cars, and they did an over-the-air update, which everybody lauded as being a great success, but I don't think any researchers have actually gone through to figure out what their integrity checking system was, right? So could you have hijacked those updates in transit and compromised them? I don't know. Anybody up for a project? Could be fun. Also, here's the problem with checksums like on the CAN bus itself. The message diversity is not very broad, right? It's not a very diverse set of messages. So it's pretty easy to actually intercept all the messages and figure out what all the checksums should be between all of them. So one of the things that's most important is don't rely purely on checksums, but also use things like policy and behavior-based detection. So for example, there's some research being done now to see how different drivers operate. Like I tend to not press my brakes. I learned how to drive on a standard, so I tend to gear down and I watch, way ahead of me. My wife, on the other hand, just loves to slam on the brakes. I almost snap my neck half a dozen times when we're going anywhere. So you can figure out how fast people are driving or how their behavior is, and then you can gauge based upon that particular behavior. And you can figure out who I am, by the way, in many ways. My mobile phone's in the car. They actually have weight sensors in seats now, so they can figure out if it's you. And then your driving pattern itself can kind of gauge who you are as well. So if I am sitting in the driver's seat, and all of a sudden I'm applying the brakes more often than I should, or et cetera, those kind of things, then you should probably take some action to remediate that, right? Because it's not really me, or maybe it's being spoofed. Or things that shouldn't ever happen. Like the left brake should never go by itself without the right brake going on, right? So that's a good way to spin you out of control and a bad thing to ever have happen. So those are kind of policy-based behaviors, and then policy-based decisions, and then behavior-based decisions as well. Also, we all know this stuff, right? Don't always validate your input. Always have buffer sanity checks, never use string copy without bounds, never use concatenated strings to do things like call databases or exec-v or anything like that, right? So concatenated strings are horrible for that kind of stuff. Make sure that random is actually random. Don't just use normal random stuff. Whoever was talking before me about the protocols had made that point as well. Is different libraries, rand is not really rand, so make sure you know what you're doing. Don't ever use default credentials or anonymous authentication. And here's the biggest problem that I see is that test the hell out of systems. You know, people who came from waterfall methodology tend to put testing off later on. And it's interesting because with vehicles and IoT, it's a system of systems, right? So test it as a unit, test it as a system, and test it as a system of systems. And also do threat modeling, right? So what is really likely to be a bad thing that happens when you're building this kind of thing? Also, pen test the hell out of it and conduct bug bounties, right? So allow people to figure out what's going on. So I haven't talked about my job at IBM, but one of the things, or much about it, one of the things that I did is I authored a paper called Design, Build, Drive. So go check that out. In fact, I think it's over here, Driving Security. And other places where there's interesting information is OWASP, obviously. Everybody should know about that. This is, by the way, this talk I usually give to non-technical audiences. I just sort of modified it for you guys. So a lot of this stuff you probably know about. I Am the Cavalry. If you saw Josh Corman's Rugged DevOps earlier, he is one of the founders of I Am the Cavalry. And then builditsecure.ly. Also, if you're interested, SAE holds a Cyber Auto Challenge. Really fun. It basically brings academia, and mostly academia, in to basically break into cars. They also involve the automakers, but it's basically taking educational facilities and they basically try to break into a car and they work with the automakers and say, hey, here's where all the problems are. So it's great fun and it actually helps out the automakers. And then, coincidentally, I just had a rather longish article published in TechCrunch today, as a matter of fact. And it's basically because I really hate fear, uncertainty, and doubt, and I know I'm a vendor and I'm supposed to sell fear, uncertainty, and doubt. That's what we do. I hate it, so I wrote an article saying who are the real threat actors and what are they actually trying to accomplish here. So go ahead and read that. One of the things that I wanted to point out, though, is that no accountant from Peoria is ever going to have to worry about somebody knocking their minivan into a ditch like I showed on the first slide here. So tone down the fear, uncertainty, doubt, actually know who your adversaries are, code for threat cases, and just use common sense and don't do stupid shit like have default passwords and string concatenation and blah, blah, blah. You guys know all the best practices, right? Last thing I'm going to leave you with is everybody asks me, what can consumers do to protect themselves? Nothing. The most ridiculous thing I've ever heard is that consumers actually have control over their fate when it comes to connected cars or IoT devices. Who uses this stuff? My aunt is on Facebook, and she posts the most stupid things. She doesn't set her privacy controls. Why am I going to expect that she's going to be able to set her Nest controls or her connected car security controls? No, it's never going to happen. Plus, a lot of IoT devices don't actually expose any sort of configuration settings to begin with, or at least not enough that we can deal with them. Plus, as it hits the enterprise market, IT people don't know how to set that crap. I remember back in the day when some IT shops were responsible for PBX setup. They never set them up properly. That was an awesome way to get into a system. Break into a PBX through the dial-in modem, do some more dialing. It's always the same default password within a certain area because it's the same installer who installs that thing, and they want to make it as easy as possible. Then you have access to the PBX. But that's not the LAN, right? So not really worried about it. But wait, executives always wanted to print out their call logs. So what did they do? They're like, we're not going to buy a printer and stick it on the PBX. We've got 200 perfectly good HP printers on our LAN. Let's just plug our PBX into our LAN and problem solved, which was the best thing they ever did for pen testers, right? Anybody ever pen test a PBX? Much fun. You can get into anything. So the point is, it's not up to, it shouldn't be up to the end users. We've got to protect the users from themselves in many cases. So that's it for me. Any questions?
Any questions?
Yes?
So is IBM building cars? How come they're paying you to do all this research?
Because we're not building cars, let me start there. But the entire ecosystem comprises cars that connect to networks, that connect to the cloud, that connect to mobile phones. And so we protect all of that stuff, right? So a lot of it's an IT problem, so we've got solutions to that, and we're also doing a lot of research into and building some solutions for cars. So for example, we actually have a group called the Cyber Center of Excellence in Israel. Works with Ben Gurion University and Beersheba, and they have come up with a solution where they put a device on the CAN bus and watch for messages, and they look for things that are anomalous. And then they send events back to a cloud-based system which does analytics across not just that car, but also all of cars, so they can detect things like vehicle-to-vehicle attacks and things like that. So I'll tell you the truth. When I came to IBM, I came from QN Labs. That was an acquisition. I've only been there for 3.5 years. I said, IBM, this is going to be horrible. I went from 240-person company to a 450,000-person company. But think about IBM. We do research. And I was like, this is going to be awesome. And so I found a place for myself. And we are doing really cool research in things like connected car, industrial controls, even home automation types of stuff. So that's really where that's where we are now. We're trying to do research and figure out good solutions that solve those problems. Sure. Anybody else want a job at IBM doing what I'm doing? Yeah. Is that it? No more questions? Come on, it's connected car. This is the most fascinating thing on the planet right now. All right, get the hell
Well,
out.
thanks. And on behalf of LASCON, we offer you a hoodie.
Oh, thank you.
Thanks so much.
Thank you so much.